Our final video of Chapter 4 is going to be dealing with isosceles and equilateral triangle. An isosceles triangle, remember, is a triangle with two sides that are congruent. The legs of that triangle are the two congruent sides. The base is the third side that is not congruent. The base angles are the two angles between the legs and the base, and the vertex angle is the angle formed by the two legs. You can see the diagram below labels all of those angles and legs. The equilateral triangle is a triangle that has all three sides congruent. A few more things we need to be familiar with. A perpendicular bisector is a line, a segment, or a ray that is perpendicular, remember that means forming a right angle, to the segment at its midpoint. So it's a line that bisects, cuts it into two equal pieces, and hits it at a 90-degree angle. So you have a couple different examples of perpendicular bisectors below. One with a segment and one with a ray. A corollary is just a theorem that can be proved easily using another theorem. It's not a real important definition, but just something you should be familiar with so when you see the term, it's not a scary or shocking term. So we have a couple theorems and corollaries. First of all, we have the isosceles triangle theorem that says if two sides of a triangle are congruent, then the angles opposite those sides, the base angles, are congruent. So, if we know that the two sides are congruent, we know that the two base angles are congruent. The converse of that says that if the two base angles of a triangle are congruent, then the sides opposite those angles are congruent. So our two legs are congruent. You can see those in the diagrams. The next theorem, theorem 4.4, it doesn't have an official name, so I'm just calling it 4.4, but you can call it whatever you would like. The name is not important. It says that if a line bisects the vertex angle of an isosceles triangle. So remember, we have the two sides congruent, so if it bisects the vertex angle, cuts it into two equal pieces, then that line is the perpendicular bisector. So if a line or a segment cuts the vertex angle into two equal pieces of an isosceles triangle, then it is the perpendicular bisector, meaning it cuts it in half, and this is also a 90-degree angle. A corollary to that says if the triangle is equilateral, then the triangle is equiangular. So we have one corollary that says if the triangle has three equal sides, it also has three equal angles. A second corollary says that if it has three equal angles, it also has three equal sides. And those, again, don't have specific names. So the three things we've talked about on this slide, again, is if we have a vertex angle cut into two equal pieces of an isosceles triangle, that line bisects and hits at a 90-degree angle. It's a perpendicular bisector. The first corollary we talked about is if it has three equal sides, a triangle has three equal sides, it also has three equal angles. And if it has three equal angles, then it has three equal sides. I know that's a lot, so take your time, read through the slides again, that's fine. Write down what information you need to know. So now we're going to use those theorems and corollaries to find the value of the variables. Well, here we have an isosceles triangle, which means the base angles are congruent. So x is 70. Again, we have two base angles congruent, so we know this is 53, this is also 53, but we know the whole triangle is 180. So 53 and 53 is 106, so our leftover is 74. Using our isosceles triangle, this is our vertex angle, so A and this angle here are going to be the same, which means that 30 plus two equal base angles has to give me 180. So if we set this up as an equation and solve, A must be 75. And last but certainly not least, we have a few things here. This one looks a little more confusing. Now, first of all, we have an isosceles triangle, and we have a line that cuts that angle in half. So we know right away C is going to be 90 degrees. It has to be because it's a perpendicular bisector. Now B is a little more difficult, but as you can see, the equation 42, and this one also has to be 42. It's an isosceles triangle. The two base angles are equal, so this plus this angle, the two base angles, plus B, and we know this is the same as B, has to give us 180. And I know that's a lot of information to take in. So take a second and read through it again. Our two base angles, 42 plus 42, plus our angle here that's split into two equal pieces, so B plus B has to give me 180. Simplify my equation and solve. We get B is 48. And we've already discussed that C is 90 degrees. So you can either know that because it's a perpendicular bisector, or we can again say that 42 plus C, we know those are going to be the same, plus B, which we figured out to be 48, has to give me 180. And so B is 48. So I apologize. This is a second setup, another way to find B, and I didn't look at this clearly. We know this is 42, and we know this is 90 because it's a perpendicular bisector, so you can say 42 plus 90 plus B is 180 because we know this smaller triangle is also 180, and you can solve and get B is 48. So I apologize. These are two different ways to figure out B. Either one is fine. So take a second, read over them, make sure you understand. And that's it. We're going to do a lot more practice with this, but make sure you have the theorems written down and examples that'll help you. Have a good night.